A good alternative to using regular ray traced lights or area lights is to go with shadow maps. And all the light types support shadow maps. If you go in the light primitive, you can see here we have a shadow map tab. So I'm just going to turn the shadow map on for the light, and you have to enable it for the region options as well. So there we go. And I'll just talk quickly about some of the advantages and disadvantages of using shadow maps. So first and foremost, they're fast. Basically, it can be used in the scan line trace mode, so no ray tracing is needed, and that's a big advantage. So you can actually go to the region options and disable ray tracing with shadow maps, and you'll still get your effects rendering. The other option is they have the ability to be hardware accelerated. So if you look on the shadow tab, there's a type where you can actually set it to OpenGL acceleration. Now, only specific cards are supported for OpenGL acceleration, and it's best to check on the Softimage site to see the different hardware cards that we do support for OpenGL acceleration. Something to keep in mind here is on a render farm, you have to be careful, because if you enable this mode and then you send the job off to the farm, and most often the render farm machines do not have good graphics cards on them because they're simply used for rendering. So you might actually end up with slower render times because you have this option enabled, because it will end up reverting to a software GL acceleration, which can be slower. And also, we've seen about 5 to 10% acceleration on large scenes using the OpenGL acceleration mode. So nothing really tremendous, but still, it's a good thing to use when you're in a preview mode working on the scene. The next thing is, once the shadow maps are actually computed, we can turn the rebuild option off, and essentially we've got the shadow map file cooked there. And if the objects aren't animated that are casting the shadows, you can actually leave that option off for your animation, and you'll save some time there. What else is there? I guess the last thing is maybe it's a property of the actual light. So you can selectively turn on shadow maps for lights that don't require the precision of ray tracing, and other lights that do require more precise shadow information, you can use regular ray tracing. So that's kind of an advantage, to be able to do it selectively on individual lights. Some of the disadvantages is it doesn't support transparencies or shadow color. There's no real notion of a shadow shader to be used with the shadow map. So you can see in this case we have a transparent object. Well, I turned ray tracing off actually, so it's not transparent. I'll just re-enable that. We've got a transparent object here, but our shadow is opaque. And again, that's because shadow maps don't support transparency. And they also don't support colored shadows. So if we try and use a color share or something to tint the shadow color, it won't work. What you can do is, on this object, actually apply a shadow shader and use a color picker to extract the shadow region and tint it through the render tree. So that's kind of a workaround for that. The other disadvantage, I guess, is the softness. It's not really dependent on how far the object that's casting the shadow is to the shadow. So you can see it's just applying kind of an even blur over the whole effect. Whereas an area light, the object that's closer to the shadow will actually be in a little bit sharper focus, and it'll blur out as it gets further away, which is a little more realistic. So that's one of the disadvantages there with shadow maps versus area lights. But again, the trade-off is you save tremendously in the amount of time it takes to render. There can also be some precision issues where sometimes the shadow, if the object actually intersects the shadow region, like you have in this case, right at the boundary, in this case we're fine because our resolution is high enough. But in certain cases, if the resolution is too low, right at the boundary, sometimes you can have it a little bit of an edge there. So the solution is to bring up the shadow map resolution. And for certain objects like hair where you have like thousands or hundreds of thousands of hairs, maybe even a million, the shadow map resolution has to be quite large because there's quite a bit of detail to resolve there. So you are going to look at like 3-4K shadow map sizes to reduce the flickering and get all the detail you want. The sample control here actually controls the amount of averaging that's done with the shadow map samples. So basically controls the blurriness or the amount of noise in the shadow map. So you can see as I bring that up, we're smoothing it out and getting a softer look. Now the bias actually allows you to shift the shadow map in space. So by bringing that up a little bit, it's actually having no effect here. Let's try going in the negative region. No, it's not really having an effect here. But basically this allows us to offset the shadow in space slightly so you can get a more diffuse look, or basically adjust the shadow for some special effects. So that really quickly is a look at shadow maps.